And if we just take that number of 1.3 million people dying each year in road traffic, that's equal to an airplane crashing every second day with 200 people, passengers in each.
Welcome back to another episode of Point B, a Cybros podcast where we interview industry experts about the latest innovations and trends in automotive technology and the connected vehicle industry.
Welcome to our Point B podcast, where we discuss the future of mobility and transportation products and services. My name is Steve Schwinke, Vice President of Customer Engagement at Cybros. In today's episode, we'll be talking with Najib El Ajjani from Cubonic about safety and security for autonomous vehicles. First, let me introduce you to Najib, who is Head of Safety and Cybersecurity for Cubonic that is based in Cologne, Germany. Najib is leading Cubonic's efforts to create the first integrated ELCV, or electric light commercial vehicle, enabling autonomous driving and connected ecosystems. Welcome, Najib, to Point B.
Hi, Steve. Great to be here.
So let's jump in. Why don't you tell us more about what Cubonic's mission is and some of the first vehicles that you'll be bringing to market?
Our main drive and our mission is to deliver exceptional value to our customers and to contribute ultimately to a sustainable future. And and this comes definitely through our modular architecture that's going to allow us to have a customer customized last mile transportation solutions. And this definitely comes through our full electrical platform, our autonomous driving technology, and our high connectivity. We have two concepts. The first concept is the people mover, and the second one is the cargo mover. And both, they are supposed to come with a level 2 or a level 4 autonomy levels, and also with high connectivity to enable a high efficient and sustainable and also safer last mile solution. The main value that we offer to the market into the transportation system is really the cost of ownership and also the availability. One of the main things we're gonna see is the reduction of the downtime and out of service time, right? Also, when we move from the internal combustion engine vehicles to the EV, we basically reduce drastically the engineering complexity and design complexity of powertrain.
Let's talk a little bit about the safety-driven approach that you're bringing with the design of your vehicles. Can you talk a little bit more about that?
If we just look at the history, when we come from vehicles that are purely mechanic, for a century now, we have developed in vehicles that were purely mechanics, and at some point we started to introduce electricity and lighting and so on. Before, I have seen in a documentary those old vehicles, they had a candle. But now, we started to introduce lamps and electricity inside the vehicle. But up to, let's say, the 60s, 70s, it was really basic electricity. Starting from the 70s, we started to introduce control units, electronic control units for basic functions in the combustion engine, like ignition timing, etc., which also helps to bring down the mechanical complexity there. But also those new solutions brought some challenges, and the challenges was safety and quality for electronics development and software. And from there, where the functional safety came up, and ISO 26262, basically to control this new technology's introduction into the market, because we have seen a lot of issues with that, like unwanted accelerations with some specific vehicles, the pedal stack, etc. And functional safety came to solve those issues and to control them. Today, if we talk about EV and electrical vehicles, that's the same thing. We are bringing a lot of solutions and a lot of advantages now to the market, to the environment, but we see a rise of new challenges. And the biggest challenge now we have with EV, electrical vehicles, is high voltage safety. And we have seen the rise of standards and regulations that controls and to mitigate those risks. And the first one, next to ISO 26262 for functional safety, it was the ISO 6469, which comes also to enhance electrical safety in the vehicles. There was the rise of legislations and homologations like the ECE R100, and also all the crash requirements around the vehicle. But also our internal engineering teams, we work together to kind of cover the loopholes where the requirements or the legal requirements, they are not extended to some points to cover all of the safety aspects. So today we have the front crash requirement, the R94, the side crash requirement, the R95, but there are some aspects that are still not, let's say, cover up, where our engineering teams does a lot of work, intensive work to be able to produce and manufacture.
But crashes do occur, and you also have first responders, right? And so do you talk or do you work with the first responder community, meaning how do you deal with an accident scene when something does unavoidably happen?
With every vehicle, there comes a manual, a safety manual for the first responders, how to interact with the vehicle and which access. I mean, as part of the ISO committee involvement when we were working on those topics, so there was also local authorities or governmental authorities from each country works also together with the OEMs and also the experts in the field to drive some guidelines, and those guidelines are also going to be shared with the parties and first responders to be more aware, customized, but also ready for through trainings. They have the right equipment to intervene and how. And there is something that the whole industry has to come to at some point, is a kind of homogeneous way of how to design the vehicle. So the first responders, they don't have to be, let's say, trained on each vehicle, or they have to check the manual for each vehicle of how to access, where's the high voltage, etc. I mean, each vehicle has its own design, but I think there should be a common point where the whole industry would align into a way how to design vehicles so the first responders also will have an ease to access to that.
How do you measure success? Like, how do you look at this and go, we are doing it the right way?
There is different ways. And one of the first ways is our vehicles needs to be tested before the release for production and before being produced. And also during production, we make sure that we're doing some end-of-life testing, that the vehicle is conformed before going to the market to open roads. There is legal requirements which are written in stone. They says this is what you have to do, this is what you have to comply with, and there is third parties that are going to come and they're going to assess those vehicles. So there is one way, and we also try to comply with international standards in the matter to make sure that we're following the trend and the safety, let's say, state of the art in a market, and also our internal engineering judgment and analysis, or our safety analysis, etc., and expertise from the teams that would bring all together. And we make our metric, and then we try to match this metric as high as we can.
Now I'm going to bring you into telling us more about autonomous driving. Is it you're doing level 4 autonomy? You mentioned level 2. Can you give the listeners a little bit more insight as to what you're doing with regards to autonomous operation of the Cubonic vehicles?
I mean, after talking about the electrical vehicle, as you mentioned, there is one parameter in the EVs that is a framework or let's say platform for autonomous drive, which is less complexity. Less complexity means less diagnostics, means less breakdown time, and means more availability. So we give the space to the AV for more space for operation, I would say. When we look to the market, to the delivery market and the transport market, the public transport, we see a driver shortage. And basically in Europe, we see that the number of shortage we have now is going to double by the end of 2030. Basically, there is more drivers that are going to go to retirement than newcomers, and there where the significance of a D level 4 in the transportation coming up in the shell and the last mile delivery business. But also we talk here about congestion reduction, shared mobility. That's a very, very important point when we look now at the cities, big cities, and then all the congestion during rush hours, etc. We'll also talk about energy saving, not only for fossil fuel here, but also electrical energy saving when we talk about shuttles and and shared mobility that we're bringing with our people mover solution. But there is something else which is very important to me personally, which is, again, safety. Today, if we look at the transportation or the roadways has the highest number of life losses, roadways alone. And if we bring numbers into perspective, today we see there is approximately 1.3 million people dying each year as a result of road traffic crashes. And that's a number from the World Health Organization. And if we just take that number of 1.3 million people dying each year in road traffic, that's equal to an airplane crashing every second day with 200 people, passengers in each. Honestly, if we bring that comparison and we compare fatalities on roadway to aeronautics and aerospace, I think we will not be producing airplanes anymore. Nobody's going to take an airplane anymore if we hear that there is an airplane which is crashing every second day. But still, those numbers, we admit them and we accept them in roadways, which should not be the case, basically. If you look to psychology, human behavior is something that is difficult to change. 90% of accidents today are caused by human error. And the main contributor is inattention. And also, if we look to the half of fatalities in accidents, the passengers did not wear a seatbelt on. So if we deep dive into that, we have speed, we have no seatbelt wearing, and the advantages of the AD technology is basically to offset the bad behaviors and to compensate the human factor, to compensate the drowsiness, the fatigue, the distraction, being drunk. I mean, an AV or an autonomous vehicle will not drink and drive. The autonomous vehicle or the robot will not have an ego and have street racing. There is a lot of aspects we're going to eliminate with the ADAS, so Advanced Drive Assistance System first, and also with the autonomous drive. I mean, just talking about the delivery business with high pressure on drivers, we start to see an increase of delivery van, also fatalities and involved into crashes or pedestrians, etc. Also, we have a lot of misbehavior there and lack of attention. And again, this is where we see also vehicle autonomy bringing an added value, and also driver assist with like blind spot detection, 360 degrees view camera, collision warnings, active emergency braking systems, which became actually compulsory by law all over Europe. We also will have alcohol interlock, speed assist, and all of those features that can compensate or offset the misbehavior or lack of attention on roads.
It's just amazing. And so these are big problems that you're tackling. Tell me how, you're going about solving that and how connectivity plays a role.
Connectivity is a big contributor into that. So definitely when we look to connectivity in AV, it's an enabler. AV cannot perform isolated. Autonomous vehicles need connectivity, but also without connecting all the aspects together, the complete ecosystem together, we cannot reach the level of availability, operation, and also sustainability that we are looking for. Basically, when the supervisor is able to track the vehicle, to check the state of charge of the vehicle, to be capable to diagnose the vehicle remotely and know what is the issue, where the fault, where the breakdown is coming from, and being able to locate the next service or workshop station. And also based on the breakdown or the failure that we have, we can prepare the spare parts already in the workshop. So when the vehicle is at the workshop, basically we have the troubleshooting, but also we have the parts, so we can quickly replace the parts and allow the vehicle to operate.
Najib, thank you for joining me on our Point B podcast today. I found our discussion fascinating. There's a lot to unpack, a lot of big topics. You're solving some very big problems at Cubonic. Again, thank you to Najib El Ajjani for being our guest today, and I'm sure we'll be talking more in the future about Cubonic's success and helping, create a future that we all want to live in. So thanks, Najib.
Thanks, Steve.
Thank you for tuning in to Point B. Join us next time for more auto tech innovations and trends. Point B is brought to you by Cybros.